The factor theorem is a corollary of the remainder theorem. Corollary means it's a theorem in its own right, but it's a direct result of the remainder theorem. It follows through directly from that. And what the factor theorem says is that for a polynomial p of x, ax minus b is a factor of the polynomial if and only if, this symbol here means if and only if, sometimes it gets abbreviated to IFF, if and only if, when we substitute b over a into the polynomial, we get 0. If and only if means this works both ways. That means if this is a factor, then that is true, but also if this is true, then it's a factor. Goes both directions. In other words, what we're saying is that b over a is a root of the equation. As an example, if 2 is a 0 of the polynomial, then x minus 2 is a factor of the polynomial. So if when we substitute 2 into it we get 0 out, then x minus 2 must be a factor, and vice versa. Now this is a very easy corollary from the remainder theorem, because if something is a factor, when we divide by it, the remainder is 0, which is what we're finding here. So this is just the remainder theorem, but in the specific case where the remainder is 0, it means that the thing we divided by is a factor because there is no remainder.